Hello, this is March 30th. This is vector equations, and this is a package you received the other day. This is going to be the solutions. So far, we have looked at vector equations in two space, in which we had vector equations, parametric equations, and scalar equations. We're now working in, we'll be working in three space in a while, but for now we're going to continue in R2 space. Here we go. Here's some things we're going to need. From grade 10, m1 times m2 equals -1. This is the negative reciprocal, lines that are at 90 degrees to other. The other thing you need is ax plus by plus c equals 0, standard form of a straight line. All right. What we saw in the last exercise, we saw the normal vector equations can be referred to as, usually use lowercase n, but I can't write it, so, and then it'll have components, a, b. That's what we're going to use today. We're going to start with a vector qp. So here we go. Q, and we're going to call this x1, y1. There is p, x aught, y aught. You can reverse these, it doesn't really matter. We're going to generate a line that's at right angles to this. Exactly where it cuts through, we don't care, but it will be at right angles. We know the slope of this line is going to be n. It's at right angles to the other one. Now, since they're at right angles, we'll be able to use a dot product. But for right now, we need the components for vector qp. So I'm going to get, from q to p, I will get x aught minus x1, y aught minus y1. From q to p, hopefully most of you are okay with this. Down here, qp is, I'm going to change this a little bit, perpendicular to n. Therefore, n dot qp should equal 0, the dot product. And I will get the components of n, which are a, b. The components for vector qp are x aught minus y aught, x aught minus y1, y aught minus y1. And that should equal 0. Do the dot product and I will get a times these two, b times these two. A x aught minus a x1 plus b y aught minus b y1. That equals 0. Rearrange this slightly and I will get a x aught plus b y aught plus negative a x1 minus b y1. Now I'm not concerned about the positive or negatives, but if you look from up here, standard form, ax plus by can be equal to c. So I'm going to get a x aught plus b y aught plus c equals 0. The fact that we use aughts and ones, not that critical, we end up with ax plus by plus c equals 0. This is the equation of a line perpendicular to qp. All right. What you should notice, so the vector we started with, the vector that was perpendicular, we used the letters a and b. There are the letters a and b. If I give you a scalar equation of a line in two space, 2x plus 5y minus 4, that means I know just by looking at it, the components will be 2, 5. If I want the slope of the actual line. This is the line perpendicular to this. This is not the slope of the line. If I want the actual slope of that line, then it's going to be the negative reciprocal, negative 5, 2, or 5, negative 2. Either one, it doesn't matter. Remember, this is the slope of the line perpendicular to that line. Okay, that's good. Let's do some exercises. Determine the Cartesian equation of a line passing through this and this. Now there's two methods to do it. Method 1. N equals 5, 3. That means M will be 3, negative 5, the negative reciprocal. You could have used negative 3, 5. It makes no difference. They're the same thing. That means y equals mx plus b. Y equals negative 5 over 3x plus b. Rise over run. I'm going to take one of these points. I don't really care which one. I'm going to use at 4, negative 2. Negative 2 equals negative 5 over 3 times 4 plus b. Negative 2 equals negative 20 over 3 plus b. Negative 2 plus 20 over 3 plus b. Negative 6 plus 20 over 3 equals b, which is 14 over 3. That means y equals negative 5/3 x plus 14 over 3. Get rid of the fractions. 3y equals negative 5x plus 14. 0 equals negative 5x plus, or minus, 3y plus 14. Get rid of the negative. 0 equals 5x plus 3y minus 14. There is the scalar equation for that line. Method 2. If I know the normal, that means I know a and b. 5x plus 3y plus c equals 0. At the point 4, negative 2, and I'll get 20 minus 6 plus c equals 0. 14 plus c equals 0. C is negative 14. 5x plus 3y minus 14 equals 0. Same thing, just easier. All right, two lines. Here's one line, there's another line. Line 1, line 2. Show if they are parallel or non-coincidental. Well, if you look at these two lines, they're in Cartesian form. If I multiply that by 2, I will get 6. If I multiply negative 4 by 2, I will get negative 8. And if I multiply negative 6 by 2, I will get negative 12. So what does that tell us? Slopes are scalar multiples, so the lines are parallel. The c value is not a multiple, so not coincident. Try it again. Now here are the lines, and they're telling me that they are parallel. Now, I don't know the slope of the line, but I know the normal will be K4. And this one, I'll know the normal is 3, negative 2. If the lines are perpendicular, if the lines are perpendicular, then here's the normal to that line and the normal to that line. They must also be perpendicular. That means K4 dot product 3 negative 2 should be equal to 0. 3K minus 8 equals 0. K equals 8/3. In order for these to be perpendicular, K must be 8/3. Okay. Nice when it works out. Third page. Determine the angle, the acute angle, formed by the intersection of a pair of lines. Now I'm just simply going to say A here is -1,3. The slope here is 3,4. These are slopes, not normals. Okay, so I have that. I would use, they're looking for angles, so I'm looking for the dot product. A dot B should equal the magnitude of AB cos theta. So I'm going to get -1,3.34 equals the magnitude of 10 times the magnitude of 25 cos theta. 3 squared plus -1 squared is 10. 16, and okay, I got that. So I'm going to get -3 plus 12 divided by square root, okay, 5√10 equals cos theta. Cos theta will be 9/5√10. Your calculator should give you 55.3 degrees. If for some chance you made a you got a slightly different answer, you will get an obtuse angle. Subtracted from 180, you'll get this. Homework. That's the end of this particular part.